No, this is like the bulk of the
Okay, so
rest.
this is the, okay.
I was hoping,
I was like, this is like probably the heaviest.
It's what I had.
Yeah.
And then turned it into a,
This introducing was the like form or
so that
whatever.
we don't try.
Yeah.
Yeah.
Prior knowledge was like the.
Yeah.
And then I.
My review.
Have to do that?
Once
I have
I'm doing mine today.
I'm gonna do that nomination thing.
March 1st.
Okay, mine meet tomorrow. Women's art. That's okay. Really?
Do you need stapler? I need stapler. Mine has pretty blue staplers. Gray.
And we'll do everyone.
No.
Oh, she teaches that now.
Message.
Really?
But.
We could break her.
This one all is
There is something, but it's not where. Right, right.
So you did
I mean, it's kind of unofficial still, but we're getting an email. Yeah, she'll probably tell us tomorrow.
Let us wonder for the rest of our lives. Thanks, Troy.
Oh my god.
I should probably tell
I think I'm gonna draw Cookie Monster on the inside.
That is honestly the
Just
best.
honestly.
Are you giving it to me? Are you giving it to me? Yeah. Is it like this?
I love it.
I love it. Here's the.
I should
probably.
You signed
I didn't sign, oh no, I did sign the inside, I don't know Shannon, but I didn't put it on the. Well, they're all going to the same house.
When do we officially start?
March 23rd, 25th.
Yeah, 25th is the last week in March.
You gonna watch the race now? Or it's not like.
I don't know, Jim.
The gym. Did you go to the gym?
No. I really gotta catch up on laundry.
Ah, you nasty. You recycle leggings, you sick fuck.
I only got 2 pairs.
Oh, jeez.
Wait, you only have
Actually,
two pairs of
it's a
leggings?
judgmental thing.
Oh my god. I can't, like, my
You can't
husband
recycle
can't
all
wrap
one
my
drawer.
My husband can't wrap I literally have like 25 pounds. I know there's some cheaper ones, but then they're
Black
leggings.
leggings.
Dude, TJ Maxx.
Honestly,
That's where it's at.
All of them.
You can get a pair for like $10.
I've done it before.
Yeah, exactly.
we didn't tell anybody about it.
Hey, she's brave.
Maybe you should just do a new pod. Start your
So yeah, mine is so easy.
Oh, you did?
reading group was supposed to be considered as, because mine is technically a social studies lesson with the ELA. Like how she said we can incorporate, that's how I did mine. Mine's a social studies
I
lesson,
talked to
but.
her and speaking, and she said that you're supposed to like try to, I don't know, like whatever.
Content area.
Not necessarily like content area, but like if you're early childhood, like typically the lesson in elementary school is gonna be like 20 to 30 minutes. So like,
40, cause it's middle school.
Because it's middle school, so. We're supposed to be.
Martinsky told me like,
Yeah, cause
No.
that's a middle
Yeah.
school class.
We're not supposed to do
So
it
that's
early.
why I didn't do early.
I mean, I didn't do early, I did like a 4th grade
Right, it had
thing, but she said like, to tailor it to like,
Well, because it's the reading 3-4-7, right? And 3-4-8. So that's the one I take for like, middle take for the content area. But early take for the 4-5 endorsement. So I think what she means by that is like, if your early child is with the endorsement, you can make it a 3-minute lesson.
yeah.
But if you're a middle childhood, just doing it for content area, do a middle childhood lesson.
Yeah.
I just made.
So I'm sure the probably range is like 30 to 45 minutes.
This is essentially what I was to do for you. This is fun, thank you.
How much was the? Really? Yeah.
Thank you. One?
So I was like,
Oh,
so I think it's the same thing.
I didn't realize that there was two there.
Multiplication, subtraction, division. And I'm gonna do it, try this with my brother. I'm my brother.
I did
I can send you the
that.
file. Please, yeah, right now. You're not supposed to share those things with teacher, please teach.
It's not, but I didn't know if we were
Don't tell
able
anybody
to
about it.
beforehand.
Somebody share some of the teachers.
I probably should have said that after you sent it to me.
Now you're not getting it, yeah.
You know how you're not supposed to share things with the teachers? I was like, would you share with someone?
Oh, call the teaching please.
No, it's not, it's just like, you know, it's an outcome teachers by it, you know, like someone put time and effort into this, you know.
I think everybody does.
Okay, well, I guess let's get started. No Caitlin today? Okay, I just handed out, a sheet that says one more, two more. And that's something that you can use with your students to practice adding one and adding two. So what you do is just take one die, and each of your students would have their own, what do you call those, tokens. Okay, so each one would have their own tokens, and one would follow the red path, one would follow the blue path, and then basically you roll one die, and you add one more to it, or two more, whatever you'd like. You can also have two dice, and on one you use them for the 1 through 6, and on the other one you just put little stickers on that say add 1, add 2. You can even have add 0 on there too. Okay? You can have your students just play it like that, or you could have them actually write the number sentence down every time they rolled it. So they roll a 5 and then add 1, 5 plus 1 equals 6, and then they move their thing. Okay? Does that make sense? Not too difficult, is that? Okay, we left off, I believe, with the doubles last time. Is that correct? Okay, so we're the doubles being 2 plus 2, 3 plus 3, 4 plus 4. All right, so you can put a pattern up or put a bunch of data on the board. Let your students come up with a pattern there, if they notice any kind of pattern. What kind of pattern do you notice with the doubles, with the answers? Okay, you see 4, 6, 8, 10. All right, so you could ask your students what you think 6 plus 6 would be. Okay, that's the next one. Or 7 plus 7. Okay, now you're giving them a quick way to figure out the doubles again. Okay? So they can basically just, you think about, you can ask them, well, how can I figure out 8 plus 8 without having to go through this whole pattern? Okay? And maybe you could you can hold up 8 fingers, you go 2, 4, 6, 8, 10, 12, 14, 16. All right, so that's one way to look at the doubles too. So the doubles, and there are skip counting by twos, so that's not too difficult for them to do the doubles. Now this book here, Two of Everything, piece of literature that you can use if you're teaching the doubles. Let's see what this book has in it. Okay, once long ago in a humble little hut lived Mr. Hacktack and his wife, Mrs. Hacktack. They were old and very poor. What little they ate came from their tiny garden. You got violins going in the background while you're reading this? In a lucky year when the harvest was plentiful, Mr. Hacktack had a little extra to take to the village. There he traded turnips, potatoes, and other vegetables for clothing, lamp oil, and fresh seed. One spring morning when Mr. Hacktack was digging in his garden, his shovel struck something hard. Puzzled, he dug deeper into the dark ground until he came upon an ancient pot made of brass. How old, said Mr. Hacktack to himself, to think that I've been digging here all these years and never came upon this pot before. I will take it home. Maybe Mrs. Hacktack can find some use for it. The pot was big and heavy for old Mr. Hacktack. As he stumbled along, his purse, which contained his last 5 gold coins, fell to the ground. He tossed it into the pot for safekeeping and staggered home. His wife greeted him at the door. Dear husband, what a strange pot, Mr. Hacktack. Dear husband, what a strange pot. Mr. Hacktack explained how he found the pot. I wonder what we can do with it, said Mrs. Hacktack. It looks too large to cook in and too small to bathe in. It's mysterious, isn't it? As Mrs. Hacktack leaned over to peer into the pot, her hairpin, the only one she owned, fell in. She felt around in the pot and suddenly her eyes grew round with surprise. Look, she shouted, I've pulled out 2 hairpins, exactly alike, and 2 purses too. Sure enough, the purses were identical and so were the hairpins. Inside each purse were 5 gold coins. Okay, so you kind of get where I'm going with this. Look at the doubles. Okay, so you have 1 + 1 and 5 + 5. Okay, so that's really what the story's pretty much about. Okay? I think eventually one of them falls in.
Comes out twin.
I think they do, yeah. I think his wife falls in. And then they begin to fight over him.
Yeah.
Okay. So we have the doubles. We also have another activity for the doubles. And it's a memory game or a matching game. Card goes, which picture is the double of what? Number sentence. Which one?
The spider's 4 + 4.
Spiders 4 + 4. Okay.
The hands are
5 + 5 are the hands. Yes.
the dog 2 + 2.
I think it is 2 + 2.
Well, the eggs would be 6 + 6 then, right?
Eggs would be 6 + 6.
Double spiders are 8 + 8.
8 + 8.
Well, 3 + 3.
Oh, cans are 3 + 3? Yeah. So we got what? 2s, 3s, 5s.
The legs 2 + 2.
are those friends that?
I think those friends are
Are
two
they?
plus two, cause
Oh,
they're
I
doing
see.
something with their
So that's
arms.
1 + 1 would equal 2.
Yeah, that would be a whole plus one.
But there
What, the
is
two
not 1
people?
plus 1 car.
There's no 1 + 1, you're right.
That's what I'm saying, I think it's 2 plus 2 has something to do with their arms.
Maybe? Sounds confusing.
Back because you're like doing something in that picture that you don't see.
I have everything out there, I believe. Yeah.
But are those people doing something that we can't see with their arms or something, with their hands?
No.
10 plus 10, I think, is the sunflower.
Yeah.
10 plus 10 is the sunflower, and that matches the, oh, actually, it doesn't match, no, that's not the sunflower.
6 plus 6 is the
The
F.
sunflower, remember what our sunflower is? 9 plus 9.
8 plus 8 is the F.
Oh, January is 7 plus 7.
January's-
Because it's actually like on here it's highlighted. 2 weeks are highlighted,
Oh.
so 7.
So did you figure out what the two people are?
So which ones?
We did 4,
Can we
6,
cross
7,
out?
5.
I would say 6 plus 6
3.
is the
We
F.
could.
No, we did 9.
2 plus 2
10
is
plus
the
10.
dog. 10 plus 10 is the sunflower.
Oh, it's the hands. So
Yeah,
like each
10.
person has 10 fingers, and there's 2 people.
Oh, I would have said 5 plus
So which
5
ones
since
did we
they're each
do?
holding up one hand.
Which ones did we do?
6 plus 6
But
is
we
the
put
eggs.
fingers.
6 plus 6.
Okay, Troy said 10 plus 10 is the sunflower.
No, it's 9 plus 9.
9 plus 9 is
9 plus 9 is the sunflower.
9 plus 9.
No, so.
So we still have 10 plus 10
Oh, we
out.
don't have,
10 plus 10.
we don't have to.
I couldn't see it from up there.
Okay, then we
5
said, what
plus
did we
5
say
is
was
your
January?
hands. 7 plus 7
Is the month, the calendar.
the calendar.
8 plus 8
Is the
dog
spiders.
3, 4 is the king.
2 plus 2 is the dog,
Yeah.
I think.
I think it's 10 plus 10 is the people because there's 2 hands and each of them have 10 fingers.
But then, oh yeah.
4 plus
4
4
plus
was the
spider.
spider.
4 plus 4 is
So
the
that has to make sense.
No, 4 plus 4 is the big spider at the top,
Yeah.
not the little one.
So it has to be 10 plus 10 because of their hands.
Yeah.
I don't like that picture at all.
I don't know. What's the hands?
Good work,
3 plus
Brad.
3.
Oh, okay. We did
Thank
it.
you. Well, maybe you guys can find a better picture, but anyway, that's, this could be a thing that you would use too if you want to put it into your games.
This is problem solving skills.
Okay? Let's see, where are we at now? So, let's kind of review what we've done. We've done the 1 more, the 2 more, the zeros, and the doubles. Have we done anything else? 4, 2 more, we started off with those, plus 1s and plus 2s. Then I think after that we did the plus zeros, correct? And then we went to doubles. Okay, now what we want to think about are the near doubles. So if I put up here, you have all those, at least some of the doubles up here. Okay. So let's combine the second 2 numbers, so 2 plus 3, 3 plus 4, 4 plus 5, 5 plus 6. Okay, so how's 5 plus 6 like 5 plus 5? Because we know the doubles, 5 plus 5 is 10. How's 5 plus 6 like 5 plus 5?
We're actually 1 more.
1 more, okay? So when I see 5 plus 6, I can think of 5 plus 5 and 1 more. So I see 4 plus 5, I can think of 4 plus 4 and 1 more. See, I'm building on something I already learned. Okay, so those are called near doubles. Yeah, but most of the students don't, I mean, they can do that too. They could go 5 plus 5 minus 1, get 4 plus 5. They typically don't like to subtract better than add, but yeah, if they want to say that, that's, anything they want to say like that, that's terrific. And for some students, that might make more sense. Okay? So those are the near doubles. Let's see where we're at here in our all right, so we've got the doubles down. Doubles we have plenty of. Near doubles, need to connect them to that. So if I'm going to get them to really connect that, I might give them a whole sheet of problems. Aim up here. Then we have one. Okay, so I might have them, give them a bunch of near doubles on a sheet. And have them think about what's the doubles that looks like this. So they would write that. And remember, they already know the doubles at this point. Okay, because every time you go from one set to another, they learn those, okay? So 3 plus 3 is 6, so 3 plus 4 would be 1 more or 7. Okay, so you're trying to get them to connect this. First off, make that connection. So that's why this line is open. Okay, so again, for this one here, it's like, okay, first off, think doubles, and that'd be 7 plus 7. Or if they'd say 8 plus 8, take away 1, that's terrific too. Okay, so they're going to write that one down here, the doubles that they're thinking of. And then this is one more, and they're trying to connect those two sets of facts. Okay? All right, near doubles, those are pretty easy, right? Okay, let's see. Now let's look at the tens facts. So adding anything to 10. So what I would do with the students is I would begin, and some of the students already have seen this pattern, but a lot haven't. And I always want the students to discover the pattern. Remember, they're using Bloom's analyze, evaluate, and create. When they create a pattern, that's creation. Okay? So I could have the students solve like 10 plus 3. Okay, they tell me it's 13, however they want to solve it. Okay, so I'm going to write that on the board. I give them another one, like 8 plus 10. And 10 plus 5. And I'm putting my data up on the board again for the students to take a look at. And I noticed, I want them to notice, when I add 3 to 10, I get 13, 8 to 10, I get 18, and 5 to 10, I get 15. What do they notice? Okay, that's the pattern we know pretty commonly, all right? But we don't want to tell them, because if we tell them and they don't understand, then they're going to memorize it, or try to memorize it, and every time they try and memorize something, they think that math doesn't make sense, and they can't figure it out. So that's why you're always trying to get them to figure it out. Okay? All right, so in this case, 10 plus 5 is 15. 8 plus 10, they see that there's a pattern there. Anytime you add a number to 10, you just put the 1 and whatever the single digit is there, however they want to say it. So then we're going to test it. So there we are in that Explorer. We found a pattern. And now we're going to, and they made a conjecture. That's the creation part. Okay, highest levels of Bloom's. And then we want to test it. So I would just ask them, so what do you think 10 plus 9 is going to be? And of course they're going to say, well, our pattern says 19. Okay, and so we're testing it. We're saying, okay, can you go ahead and check that? And they count their fingers, they use manipulatives, put tick marks, however they want to do it, and they come up with the thing is working. Yes?
Does this only work with single digits? Like if you were to tell them 10 plus 11, will they write 111?
Oh, well, I would let them try it. Okay. So just what you said now is working only with single digits. So if they, now I wouldn't introduce that, But if someone would have said, okay, so 10 plus 11 is 111, okay? I would just say, okay, can you check that? All right, and they would check it and say, oh no, it's not coming out to 111. It's a lot less, okay? And maybe if they started down that line, I would probably say, okay, what about 10 plus 15? 10 plus 21, okay? And I start to see, so what's different about those? Okay, so what's different about these problems where it's not working and the ones that it is? And so that's again where they're kind of looking, doing the analysis and the evaluation. Okay, they have to be less than 10 or however they want to say it. There want to be one number there, they might say it like that. Okay? So anytime the students, if you can, anytime the students ask a question, you always want to just kind of turn it into an opportunity for the students to figure it out themselves. So you follow down their line of reasoning, and like I just did, and then you just kind of leave it open to the class. Now, I will say it is tough to always do that because, I mean, I just happen to think of this just now, okay? But there's a good chance if I was in front of a class of first graders, I might not have thought of that. So I might have had to say something like, okay, let's look at that. I might have followed it for a little bit and then said, okay, well, think about that, and we're going to look at that again tomorrow. And that gives me a chance to think of something. Those kinds of things, though, they're hard to do because, you know, when a student throws you off like that, it's hard to think, oh, okay, I'm just going to, you know, rather than saying, no, don't do that. You can only do it with single digits. You know, it's hard to, because they catch you by surprise. So that's like a habit you have to kind of like get used to, like students catching you by surprise, and then you say, well, that's a very good question, let's try it. I see what you're saying. Anybody have anything to say? No one has anything to say, and it's like, well, let's think about that tomorrow. It gives me a chance to talk to another teacher or something, figure out how to handle that. Okay? Okay, so those are the 10s. Now, what I'd like to do is take a look at this video. There's this video that they're exploring. What happened to my video? There we go. In this video, they are, I think it's here, multiplying fractions. Where did that come from? There we go. All right. So basically, they're just looking at the numbers, the 11 to 19. But I'm bringing this up to kind of show that they're doing a few things that we talked about. They're using the 10s frames with the students. It's a kindergarten class. They've used the 10 frames a lot, which you could have used with, by the way, adding 10 plus 3. You could have had two 10 frames. And they recognize, and you can see that these students start to recognize what 2 looks like or what 5 looks like, just by looking at the 10 frame. Remember we talked about that subitizing? They just look at the picture, and then that's what they know what it is. You don't have to count it up. And those are the sheets I handed out first thing today, the subitizing sheets. Okay? They're also going to talk about a lot of other different math practices and content. And you'll see kind of the way I'm showing you how to teach, how this teacher is doing it herself.
Hi, I'm Karen Laster, and I invite you to join my kindergarten class as we explore this lesson, Beyond Fingers. Very good. When we were working at our desks in our journals yesterday, I noticed that you guys could get this part. You understand that the numbers from 11 to 19 on our number line right here, the heart of this lesson is working with the numbers from 11 to 19. And in the Common Core, it has a different approach to that. They're thought of as 10 and some more ones, and it means that we have just one. So that would mean that we have just one. This number right here means that we have 10. They're working with the 10 frame, and that's pretty familiar to them. And now I'm stretching it to the numbers that are 10 and some more ones.
Because 2 plus 8 equals 10.
Very good. Okay, I'm going to ask Alexia to come up and prove that. One of the ways that you can get a proof out of a kindergarten child is to give them manipulatives and just ask them to prove whatever it is that they've said. Okay, tell me what you're thinking while you're doing it.
I'm going to put the 2 and red and the blue and 8.
Excellent, okay. Kindergarten mathematics is very conceptual. You're trying to build that conceptual base that you can then lead into the abstract. And so their reasoning is very much tied to the concrete items that they're using. So when you say prove it, then they can prove it with manipulatives. That is their proof. That is their type of proof for kindergarten. Who can just look up there and tell me if that's 10? Olivia, how do you know?
Because it's a 10 frame and we can have 10 in the 10 frame.
Okay. So the 10 frame is full, so you know that it has to be 10 in there because it's full. Okay, but what if I did this? Moving the magnets around on the whiteboard is a good way for students to begin to make those connections between what they know and how it doesn't change. Okay, so now how many do I have? Armand?
10, because you just move them around. You just take any way up it and
So when I move them around, it's still the same. Is that correct?
yes.
Well, now what if I did this? Justin,
12.
how did you know that? That was very fast.
Because you put 2 in, that makes 12.
Okay, and how do you know that that makes 12? What did you do? What did you think? How did you think from 10 to 12?
I knew the 10 frame was 10 and then I counted fast 12.
Okay, so you started with a 10 frame, and then you went 11, 12. Is that what you did? Great job. That's good thinking. Now what if I do this one? You ready? All right. Aiden.
12.
Students come with different knowledge levels.
12 I was counting in one frame.
Okay, so you're just counting. Did you start here?
Yeah.
Okay. He was really not counting on from 10, but he was counting them all. So he started with the very first one and he counted all.
9, 10, 11.
11. So how many are there?
11.
You don't want to stop their learning because they aren't where you want them to be for the next lesson. So what you try and do is take where they are and build them continually with the knowledge that you're learning now, but also fill in that gap so that they can get there. And you notice that she put the 1 right here. Who knows what that 1 means? Armand?
It means 110.
110. 110. This means 110. And we put it here because if we did this, where we put the 0 here and the 1 here, what number would that be? Dutch?
1.
1. They've worked really hard this year, so they have cardinality, which means that they can take a set and I can move it around and they understand that if none have been added or taken away, it's still the same number. They have worked with a 10 frame. They understand that a 10 frame is designed to help them with the number 10. They have done counting on from a number, any number, and so all of those little pieces fit together to build a foundation on which to build this lesson. But the numbers from 11 to 19 are tricky numbers because it doesn't sound like what they are. So it says 13. And yesterday I saw somebody look at 13 and say, this is 13.
That's 31.
That's 31. How can you tell that's 31?
Because the 3's in the first spot and the 1's in the second spot.
Right. And that's why it's so important to know how the numbers work together. We started this yesterday. They knew the numbers right away. So they knew that 10 and 3 more was 13. But what I noticed was that they did not write the numbers correctly. The connection that they were missing is the place value connection where you write the number of 10s first and then the number of 1s. And so based on that, I altered the lesson to include more of how to write the numbers and less of identifying the numbers. Okay, this is what I want you to do. We're going to do a little work in our journal. The math journal today covers the numbers 11 to 19. So what I want you to do now is draw a circle around 10 sailboats, and then count how many more and come up with a number. And I'm just going to walk around and look. In today's journal, I put all kinds of different graphics, and I tried them in different formats. I tried them set up as if they were in a 10 frame. I tried scattered, because I wanted to see if children could make sense of numbers in a scattered format. So if you start counting at 10, can you count on?
Yes.
Okay,
So,
do it for me.
10, 11, 12, 13.
Okay, so what number should be the total for that page?
13.
Good, can you write that? You got one right here. I think that we have a little difficulty with the boats today. Who can tell me why it was harder for the boats today? Dutch.
Because they're not set like a 10 frame.
Okay, they're not set up like a 10 frame. I think when you're doing a lesson, you have to watch for how is the lesson developing. The lesson first developed with the modeling and student interaction. From there, it went to them writing it down and a kind of formative assessment. From there, it went into the individual journals, which is their accountability piece. Okay, this 10 frame is absolutely full. So how many kids do I have sitting here? 10. And how many do I have back there? This lesson is really important for kids. We as adults tend to think that learning to count is an easy kind of thing, but it is not. It's really hard work. Numbers up to 20 are crucial understanding for all kindergarten children.
All right. There are quite a few things, quite a few ideas in there that we've talked about in this class. Could you find them? Find some of those ideas. Yes?
Like idea of concrete abstract, she was starting with, she used arranged formats, like use the kids as the manipulative, and then she had the kids model with the magnets and the 10 frame.
Yeah, very much concrete to abstract. Yes?
One way I like that she took, started the process of going from concrete to abstract instead of using concrete was, when she was using the 10 frames, she just moved them out of the frame,
Yeah.
and that was able to help the children move to the next step without depending on the 10 frame.
Yeah, yeah.
I really I actually wrote a note that because I just thought that was really
Yeah, that's interesting. That's a really good point, because remember we talked about like students, especially kindergartners, they estimate, and you know how 6 and 7 is really big. Well, now they see 10, they know 10 in the 10 frame, and now you push it up, and now it's like, okay, that's what 10 looks like.
Yeah.
Okay, so they're getting a much stronger number sense. Okay, what other things did you see in there? Yes.
Just the fact that like she realized that they weren't understanding how to necessarily write the numbers. So
Okay.
she like kind of changed her lesson from like identifying what numbers were to like how to write them.
How to write them?
And
Yeah.
like the place values and stuff.
Okay, and do you see how the students who are writing it backwards probably understood the concept? You know, 1, 10, and 3 ones. They just were writing it the wrong way. See, the abstract part is the hard part for them at this point. Kayla, did you have your hand up?
Yeah, I was gonna say that I liked, when they were working on her journals and she said that she used some of them in 10 frames and some were scattered, that she knew it was gonna be a challenge, or she was at least expecting it, and so as she was walking around, she was making observations, noticing that it was a challenge for the students, and so instead of just not really pointing that out to her students, she said, hey, I noticed that some of you were struggling with
Yeah.
this, with the boats, and I know for me as a student, when I am struggling with something or I feel like I got it wrong, I don't wanna think about it really because I feel like everyone else got it right.
Yeah.
And so I don't feel, I don't know, so I just
Yeah.
felt like it helped those students that were struggling to say, it's okay that I'm struggling and let's figure out why.
Yeah, so she makes it into a conversation
Yeah.
for the class, and that's really, I mean, that's a great point, because, you know, without doing something like that, you know, the students would be like, a few would be isolated, thinking, okay, I'm not very good at this math thing. All right, so she's saying, yeah, we're struggling with this, and then she's asking them why. These students have pretty good communication skills, you know, for kindergartners, they're doing pretty good.
Yeah, I was just gonna say, I really like how she did a really good job of facilitating them through like questioning.
Yeah.
Cause like, the way things are, so that's 31, and instead of just saying, yes, you're correct, and moving on, she's like, how did you know that was 31?
Yeah.
So like every answer, there was a follow-up question for rationale.
Yeah, she is doing a lot of questioning. That's the way she's moving the lesson along, okay? Which means the students have to provide the answers, which means they have to think about things, and that's, again, the higher levels of balloons. Okay? Said a couple other things. She noted that they have to prove it in their own language. Remember, like 2 + 8 is 10? And she said you could use manipulatives to prove it in their own language. Okay, and that their languages, we talked about that in here, the concrete. Okay, so they actually can prove things at a very young age of talking about doing something like that. Conservation of number. Remember how she, and again, how she took the tens out and she moved them up, and she said how many are there? Tens, that's cardinality. That thing didn't change, and they showed you like the content standard that's meeting. So nothing changed, it's still 10, you don't have to count over again. We talked about that in here. Counting on, okay, so she asked them, like she had a 10 frame and she had 2 individual magnets, and the one said 12, how did you get that so fast? Okay, now they aren't gonna necessarily say counting on, but you have to kind of interpret what they're doing. And he said something like there's a 10 and 11, 12, or 10 and 2 more, or something like that. Okay, so you can see he was counting on. Because of course the subitizing, again, they saw the 10 frames, so they know that there's 10 there. The teen numbers we talked about, how difficult those are. And she even mentioned like the name 13, okay, 14, unlike 24, 23. We talked about that before, the counting backwards. She's also, the whole lesson's about looking at 11 to 19, and that she's connecting it to the 10s. Okay, so she used the 10 frame, the 10 and the 2, that was 12. Okay, so she's basing it upon their knowledge of 10. Okay, and of course their knowledge of the single digits. And that's kind of what this is all about up here. All right, basing it upon 10. All right, so that's another exploration. Now she had the students, when she had the 31 and the 13, one way that they are building their base 10 concepts, and you saw it there by using the 10 frame. Okay, so they know that they have 1 10 if they fill one of these up, and then whatever's left. Okay, so she pointed at the 1, she said, what does that mean? And the one boy said, that's 110, something like that. So I'm thinking that they probably were using maybe two 10 frames together. Okay, like I gave you all 2, and the 1 would fill up, and then she was probably matching that. Every time 1 would fill up, and you had 3 or 4 in the second 10 frame, that maybe she was writing the numbers on the board and saying, okay, we have 1 10 frame. How would this tell me that there's 1 10 frame up here? Like this up here, this would be a 1 and a 3. Okay, so 1 whole 10 frame and a 3. So she would have a whole 10 frame and a 3. And then she could do this one next. Show me 18. So 18, they fill in 10 and they have 8. You know, she could say, what do you notice about that? Okay, then she has a 10 and a 5, so they fill in all 10. Then they fill in 5. She said, hey, look up here again. How many 10 frames did we have? Well, we had 1 here, 1 here, 1 here. How could you figure out how many 10 frames you're going to fill? If I gave you a number like 14, okay? Then they could say, well, that 1, you know, they're connecting it. That's a much better way to get them to see place value than to do what, at least the way I was taught, I think most were taught today. Okay, we were taught, at least I was, that this is the 1's place, this is the 10's place, and it's the 100's place. Now I always have to remember that, memorize that. And I never really understood it. Okay, I just knew I had to know, you know, 100's, 10's, and 1's place. Now, if you use the 10's frame, you could get them to realize this. It might be a lot of 10's frames though, especially for, you know, like even for 27. If I just looked at 27, they're going to have 3 10's frames. Okay, so I might use the base 10 blocks, and probably the 100's I would wait for kindergarten. but I would have them, first off, we've got to introduce the base 10 blocks. I'm not sure we talked about that here in this class. So before I introduce even the tens, I'd have the students using the ones or the units and just counting them. That's another counter. Okay, so you have a lot of different counters. Okay, you have pennies, for example. We talked about using pennies for counters, using the little circles for counters, and so on. So I could have them counting these up here, 1, 2, 3, and so on. So maybe in early kindergarten, that's what they're doing. They're just learning their numbers. When we talk about learning the numbers, what the number 5 is, and so on. And they use these as one of their tools to learn what the numbers mean. Okay? Now, once they become comfortable with this, I might have them line those up and then introduce the 10 stick. Okay? So I'd have them go ahead and line up, count out 10, and line them all up. They haven't seen the rods yet. These are usually called rods. I mean, I'd call them tens if I was in kindergarten. And I'd say, what do you notice? Okay? And then they can see in here, I know that this doesn't show it very well, but the lines are on there. Okay, this means 10. All right, so now I've got them looking at this as being a 10. That's my way of introducing it rather than telling them and saying, this is called a 10. Sort of like with a nickel, saying, well, this is a 5, you just have to remember it. In that case, they have to remember it, but in this case, they can figure it out. Okay? So when I was asking them before we had the tens, I'd say, show me 13. You know, they'd show me 13, you know, it'd be all scattered. Or they'd show me 18, or they'd show me 24, and it's all scattered with the ones. Now I could ask them, how could you show me, you know, 15 using a rod, a tens? Okay? So now they show you what I said. There's a 16. Okay? So that's one way to do it. A second way is to have all 16 little cubes, which is what they've been doing prior to this lesson. Okay? So I could have them show me 24, and they could show me 24. Okay, that right there. Another way would be having 24 little cubes. Another way would be to have 1, 10, and 14 little cubes. Okay, so a lot of little different ways that they could do these kinds of things. Now comes the part that kind of generated all this, you know, why I brought these in, and that is place value. So here we are in late kindergarten or early first grade, and now they're able to use the base 10 blocks. Okay, they can use the ones and the tens. Okay, so that's where they're at right now. Okay, and now I can have them start to show me different numbers. Like I could say, you know, show me 24, 32, and 18. Okay? Now with these, as opposed to the 10 frame, it would take, what, 4 10 frames to do a 32. And that's a lot of space on the desk. And they don't have a lot of space on the desk. So now using these, I can be a little bit more efficient. So I can show 24, 32, and 18. Okay. Okay, so I can say, you know, show me 24. They have it on their desk there. I can say, how many 10s do you have in 24? How many 10 rods did you use? 2 of them, okay. How many did you use for 32? 3, okay. And how many ones were left? 2. How many did you use for 18? 1 and then 8 were left, okay? And say, did you notice anything about the number of 10s that you use and the number 18, or the number of 10s you use and the number 32? And there's the place value. It's saying, okay, that's telling me how many 10s I need. Okay, that first one. So that's the place that tells me how many 10s I need. The tens place. Okay? And they can figure that out. So now I can put on the board a number that's much bigger that they haven't seen before, like 84. And say, okay, I'm gonna put, let's try 84. How many 10s do you think you're going to need? Okay, okay, then go ahead and do that, and let's test this out. So here again is that explore, find patterns, and the students are figuring it out for themselves. And that tens place really makes a lot of sense now. See, to me it never made sense until I started teaching this class. Okay, it's a number of tens I'm going to use. So 84 would have 8. So I get the 8. They show me 84, and then I let them count. Count goes up, see if we really do have 84 little cubes there. Okay, and sure enough they do. I can also be counting, because a quick way to do this would be counting by tens, which we've taught them. Remember, they're counting by 2s, 5s, and 10s. Okay, so I can also break that into 10, 20, 30, 40, 50, 60, 70, 80. And by the way, that's a tough thing. We saw it in, I don't know if we talked about this in the money, I wish we would have. But they get into one type of pattern, and it's hard for them to change. So there will be some students that will go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So they get into that pattern. Remember when the students were trying to count backwards and they grabbed the wrong pattern? They'd go 22, 21, because they kind of have that pattern. They get to 20, and then they had trouble, so the next pattern in their head was the 10s, 30, 40, and you could tell by the look on their faces, they knew something was wrong, which is really interesting, okay? So anyway, so that can happen here. When they switch patterns, even counting like this, it's very difficult for them, okay? It takes a lot of practice. And that happens a lot with money. So if I had 6 nickels, and 2 pennies, or nickels, dimes, and pennies, it's very difficult. You'll watch it, they'll start 5, 10, 15, 20, 25, 30, 35, 40. They often will do that, okay? And so, I don't know if I handed this out or not, but I'll have to make sure that I hand this, I think I did hand this sheet out, but I can't remember. Did I hand out something where it had like the dime and then you turned it over and there were 10 pennies there? I mean, it was a sheet that had like maybe 4.
You gave us one on nickels. You gave pennies and nickels, yeah.
Yeah, I think I did, but I'm not 100% sure. If I did, I want to give that to you. But it was a 2-sided sheet. Okay, so it had the quarter. Then when you turn it over, there's 25 cents, 25 pennies there.
Why don't we get that one?
Okay, I'm gonna have to give that one to you. All right. Anyway, so that's the way you can help them to figure it out. Remember, we're always trying to help them to figure it out on their own. So they go 5, 10, 15, 20, 25, 30, 35, 40. You say, okay, you're saying 40. Now turn over those sheets, and just so you know what those sheets are, the sheet has a nickel on it, and on the opposite side, it's got 5 pennies. Okay? So I would say to them, okay, now go ahead and check that. And so they would take, 6 of these sheets and put them down, and then they would turn them over, and then they'd have 1 and 2. So they'd have the 6, 30, and then they go 1, 2, and say, okay, what did you do wrong? Let's go back again and see what you did. Let's see if we can figure this out. 5, 10, 15, 25, 30, 35. Okay, now we're starting to see. We already went over it. Why did we go, we only have 32, we're all the way over it. Okay, now, it kind of gets them thinking about it. Okay? All right, so I'll make sure to give you get those sheets to you. Okay, so I think what we'll do is we'll just take a 5-minute break, and then we will look at making tens, because we haven't hit all the facts yet. All the basic facts.
You can write it. Can you send me like, never mind, I'm not gonna do it today, but I was gonna try and work on it today, but I forgot that I wanted to do my tax day first. Or like, I think it's like one class and I don't know where I literally don't do that time. I'm doing it AirPods, so it's like really easy, it's like 8 slides. Yeah, so it makes it easier. Yeah. I'm doing fractions. I'm hoping my CP placement will be in my 3rd grade classroom for methods 1.
Oh,
So, I figured, why not do something that I could use in CP?
yeah. It's a lot of students. Let's see. Quiet today.
First, my work, I would want to my OT on. Because the 12 is, almost a choice. So you know.
Then you have to look at places in your semester, right?
It took me an hour to read it up to early childhood. There is one. No, that's the APK.
Do I just?
I'll choose your starters for your. It's almost a choice. So I can opt for that. But I leave it at one.
Great, you can help them find
Yeah.
out. It's all kinds of stuff.
Hey, I have to really teach me about that. I have a, so with that, I didn't sign up for it, but so I go, and I was like, can I still go? I'm sure you just put it, I got home. Are you gonna go? Yeah. Just leave. I feel like it's literally, I went to bed.
I did something, and so maybe I can be more experienced, but like, I know the time it's like, I didn't work like that, but people don't show up, so I'm just like, it's only 2 hours.
I was in the grocery store.
Well,
Like
Saturday?
8 to 12.
Yeah.
And I slept for an hour and a half before that.
Alright,
So.
Cool, then email, but it's
Well,
just
that's
right on the Google thing, just put your name.
Fill it out and say that.
If there's literally like 3 questions, you put your name, put your.
Are you going? Because I have 2 classes, but I don't wanna use.
Just
something
know
already.
that.
I just.
Okay, do you have your double tens frame that you could do that for me? Put 9 in one and 5 in the other, you just need one between 2 of you, if you have. tens frame. I did, give you 2?
You mean before?
Yeah, before today.
Yeah.
Oh, before.
Yeah. This isn't earth shattering, but it's why I use it handy, so. If you don't, you can just imagine a 10 frame, 2 10 frames. Okay. nines facts, adding with 9, okay? So what I can have the students do is, again, if they're using the 10 frames a lot to add, I can have them represent 9 plus 5. I could say, what happens if I move this one over here? Now what's the problem? 10 plus 4, which is pretty easy, right? Because we just did the 10s. Okay, so now what I'm going to do is I'm going to learn the 9s facts by thinking of a 10s fact. I'm making 10s. Okay? So 9 plus 5 becomes 10 plus 4, which is real easy, 14. So 9 plus 5 is 14. Okay? And there again is that conservation of number, the cardinality, that just because I moved it over, I don't have to recount everything. Of course, at this point, late kindergarten and first grade, that shouldn't be an issue. Okay? So I can have them try another one about 9 plus 8. All right. So we have 9 plus 8. And I can take one of these over here, make it 10 plus 7, which suddenly becomes a very easy problem. 9 plus 8 is 17. All right. And I could do another one. 9 plus 3 becomes 10 plus 2. And now what I'm doing is setting up my data so my first graders can see a way to do it without having to use the manipulatives. So I can say, okay, 9 plus 5, what you know is how's 10 plus 4 like 9 plus 5? I say the answers are the same. I say compare 9 to 10. Okay, when I made that into a 10, it became 1 more, so I took, where did I get that 1 from? Okay, I got it from the 5. All right, here we're going concrete to abstract again. Okay, so what I'm doing here is I begin with 9 plus 5, and I made it to 10 plus 4, which was real easy for me. Okay, bless you. So I made a 10, I made the 9 into a 10 by taking 1 away from the 5 and bringing it over there. Okay, that they will understand. If you don't use the manipulatives, they will not understand that. Okay? So if I was a teacher and I said, okay, let's do 9 plus 6, and I'm introducing this idea, and I say, take 1 from here and put it over here, they are not going to understand that, because it's all done abstractly. If I do it concretely, now they can tell me. I can say, okay, how did I go from 9 to 10? I took 1. Where'd you take the 1 from? Well, from the 5. Where's that up here? It's right here. See, I just keep asking questions. I want them to tie their movements, the concrete, to this abstract. So I took 1 from here and brought it over here. Now they understand it. Okay? It's not going to be something that they're going to memorize. Okay with everybody? I can do this with the 8s as well. So the 9s and the 8s. Okay, you can eat the candy, that's all we're using it for.
Great.
All right, so. Kind of reviewing where we're at. We're looking for the basic facts mastered in first grade. We are talking about memorization, but we're talking about them making meaning of the facts. Like we just did the 9s fact attached to the 10s fact. We okay? So excited when they get the candy. Okay, so this is basically the overall strategy. If you remember again, we did the horizontal number sentences, which you see there, the commutative property. Remember, we're cutting the facts in half. We did word problems, class situations, we used manipulatives. The most important facts of all, because subtraction and multiplication rely on them. And here's basically what we did. We did the one more than and two more than facts. We set up a pattern, and we asked the students, what do you always notice? The zero facts, we have two different patterns, okay? The first pattern is just to get them to write plus 0. Okay, that's a tough thing. The second pattern was used then for them to find that anytime you add a 0, you get the same number, whatever number you're adding it to. Okay, so they're setting those rules. The doubles, we have the two of everything book. We had what was it, the memory game. Oh, we had the one more than two more game up here too. So we have the memory game, and then for the harder ones, 8, 8, 16, 9, 9, 18, we actually had things set up in class that we would use those phrases over and over again. I could do it with 7 plus 7 too. All right, so in class we were doing, for example, every time we were going to lunch, I would say 8, 8, 16 wait, and that became the signal, and now they know what 8, 8, 16 wait is, and now it's just a matter of just transferring it to the addition problem. Okay? The near doubles we talked about, one away, you can do it with two away if you'd like. One away is the easiest one, and you can subtract. We did the 10 facts with the 10 frame. I mean, I didn't really use the 10 frame to set up the pattern with 10 plus 3. I don't think I used it when I was doing that. Again, we're looking for a pattern. The 8 and 9 facts, we're going to make 10. That's what we just finished. And now if we do all of that, pretty much with meaning, where the students are figuring out all those patterns and their shortcuts for adding these, all these addition facts, we have only 12 facts left. Really 6 plus the commutative pairs. And so now I can put those on the board, and I could ask the students, how might you remember those? And this is about the only thing they really have to memorize, okay, without meaning. Or they might find meaning, like they might say, well, 3 plus 5 is like 3 plus 3 and 2 more. Okay, so someone might say that makes sense for you. You know, whatever they would want to say for those 6. Okay? But that's what we've come down to, our 6 facts really to memorize, and of course the commutative pairs. Okay, a lot less than probably what most of us did in here. You had 100 facts to memorize. Okay? Any questions about this? No questions? Okay. Let's see here. All right, so we have the commutative law of addition. 3 plus 2 and 2 plus 3. How might you, and you can talk with a partner here for a few minutes, how might you teach the associative law? The associative law of addition is where you have 3 or more numbers. And you can move those numbers wherever you want them. That's what the associative law is of addition. Okay, so I can make it 5 plus 2 plus 4, 4 plus 5 plus 2, and so on. How can I get the students to figure that out? Want to talk about it for a few minutes? associative law. Any ideas?
Any way you add them, they're gonna be the same.
Okay, how do you get your students to say that? Tony?
So, we discussed with all this candy you just gave us. Then we just let them put them in groups, and then add them, and then switch the groups, and then add them, and then switch them again. And so they can just see that it doesn't matter where you put it in. It's always the same if you're adding them.
Okay, Laura?
That was kind of what we did, like, lead them through, like, that example, and then give them like 3 different numbers, and have
Okay.
them kind of experiment with that, and like, you know, observe what their hypotheses are. Okay, let's try again. And
Yeah.
like do a few sets of numbers and have them mix them up and add them.
Yeah, I mean, basically that's it. You would have them, you give them 3 sets of numbers, so they represent them with blocks or with candy, 4, 2, and 5. Okay, and you might even keep them so that they're all, each were on a different little plate or piece of paper, so they can just move them around real easy and keep them as the units. You'd also want them to write down the problem, so as they would move them, you say, okay, every time you create a new problem, write down that problem. Okay, so now they're moving it because you got to go from the concrete to the abstract. So basically, yeah, that's it. So as they're writing all the different ways they can do this, and they figure out the total, you can ask them, well, why does the total not change? And they're going to tell you, again, no, well, nothing changed. They're not going to have the greatest explanations. Okay, but they're going to understand it. And then you could say, well, the numbers look very different. They've moved all over the place. Why wouldn't it be different? And again, they're going to just tell you. And then I could say, okay, you think it's always going to work that way? You think if I chose any 3 numbers and did that? Okay, well, let's do an experiment. Okay, just like you had said. So I pick another set of 3 numbers and let them go ahead and work with that and see if the thing was working again. All right, so there's again my way of, actually your way of figuring out how to get them to figure out this law. They don't have to know the name associative law, they just have to know the concept. Okay? Very good. Right, so let's see what we have here. Types of subtractions. Now we're going to move in, before we move to subtraction, I just gave you a sheet. It says target 50. There's one you can write on if you want, and the other one you can keep for yourself. Just like it says there, it says choose any 4 numbers. Place each in a corner circle. So choose any 4 numbers you'd like. Put them each in a corner, put them in the corner circles. Maybe I'll just do it up here. So I choose 7, 3, 5, and 4. Okay. And then what you do is, any circle, any open circle between 2 numbers, you add those 2 numbers together and put it in that circle. So 7 and 5 would be 12, 7 and 3 would be 10, 3 and 4 would be 7, and 4 and 5 would be 9. Now I have some more open circles between 2 numbers, so I add those 2 numbers. 12 and 10 is 22, 10 and 7. Okay? And now I have 1 circle that's left between these 2 numbers. So I add those up, so I get 38. Our target can change, but the target here is listed as 50. Now you can make that target whatever you want, depending on the level of the students. Okay? But this student, me, I didn't get to 50, so maybe I'll try it again. So if I have this laminated, or at least I did it in pencil, I could try it again, but you see that's me practicing my addition. Okay? And it's giving them a goal, something pretty interesting to do as opposed to just doing a sheet of problems. Okay? So you can ask them, okay, who got the closest? Let's try it again. All right? Any questions on that? You can make the target be 20 if you want. If you're talking with the early 1st grade, maybe the target's 20 or 25 or something like that. So this might be more appropriate for middle and late first grade. You could use this for, you know, second and third grade as well. Okay? Now, if you wanted to, you could laminate sheets like this and use that for your game too. One of your games. Okay, you wouldn't have to worry about the markers. And before you do a lot of lamination, did I say in here, just don't spend more than $7? I don't know if I said it in here.
You might have said it in our other,
Oh,
I don't think you said it in this class.
Yeah. So don't spend, I mean, if you're gonna, I mean, you can spend as much as you'd like, but if you're getting up to like $6, $7, you might wanna check with me. Because, you know, you shouldn't have to spend a lot of money. So then I would probably just cut it back. Like, for example, if we're gonna take this and do this, well, for 24 students, you need 24 of those sheets. That's a lot of lamination. So you might just come to me and say, you know, I don't wanna do 24, then I'd say, okay, just do 5 or something like that. Yes?
You know that if you print that out and you put it in one of those protective sheets, you can write out those clear sheets with.
Yeah, that's a good idea.
And those are like really cheap to use.
Yeah, that's a real good idea, the sheet protectors.
Yeah, the sheet protector.
Very good idea.
Why don't we bring her along?
Huh?
That's why we bring you along.
I know, right? It's not just,
You're not better than.
there's a smart one, there's a pretty one, there's a funny one. I'm smart and funny and pretty.
There's always one of them in the group.
I'm
There's
the
always
triple
one.
threat.
She's got it all.
I know, I'm the old lady who's funny when you over, so everybody like her too.
You're so versatile.
You guys keep it around for a reason.
I really do.
All right, now we're going to subtraction, and addition is extremely important because subtraction, you're going to see, is going to rely upon addition. I would introduce it the way I introduced addition. So you remember I had like the turtles up here and the frogs up here in the boxes. So I might use something like that. I might have like 7 turtles up here and say, you know, I gave 2 to Lauren, how many do I have now? And so the students kind of see that. They can model it with their own little blocks on their desk. You know, they have 7, they take away 2. So I do a few of those. It's not a big deal for them. You know, for a kindergartner to have blocks and give 2 away, that's no big deal. And then it's a matter of translating that concrete to the abstract and then saying, okay, what did you begin with? Okay, how many did you give away? How many did you have left? All right, you say you began with 7. This means take away, give away. So you give away 2. And now how much do you have? And that's actually the same meaning we had before for the equal sign. Now how much do you have? Okay? And then I do another concrete one and then do that abstract thing to make sure you know what the minus sign means. I'm not really using the term minus yet. Just trying to get them to understand the concept. Do another concrete, then abstract representation, and then at some point I'm going to say, about using your blocks, what do you think the answer here would be? Okay? And see if they can figure out, okay, that means 8, take away 3, and they get 5. Yes?
So I thought it was always easier for me when I was little to add and subtract, of course. So at what point do we tell the kids, start at 3, go to 8, and that's your answer?
Oh, to count up?
Yeah.
Well, I would let them say it. In other words, I'd say, well, how did you do it? And one might say exactly that. Okay? So some might say, well, no, I looked at my fingers in 8, and then I just put down 3 and 5. Okay? So I'd let them, at least I'd give them a chance to. And probably initially I wouldn't, well, you're going to see here where it's going to occur to them very, very soon here. Okay? Okay, so this is just be introducing, and then later I'll talk about the minus sign. What you're talking about is the basic facts, which is the next step here. So basically, the basic facts, so in first grade, we want the students to be able to say 8 minus 3 is 5, not have to think about a lot of stuff. So, now we're in basic facts, bless you, in first grade, and now they know this is a minus sign, they know this is equal, they know how to subtract, okay? How are we going to get them to learn all their basic facts with subtraction, okay? And so now what I would do is, I would say, So when I do 12 minus 4, I'm going to say, you know, we just spent, you know, 3 weeks or 4 weeks learning all those addition facts. Excuse me. I'm going to try and think an addition fact that's like this one here. So I know 4 plus something equals 12. Okay? And what's that fact? 4 plus 8. Okay? So think about the 8. You take away the 2, take the 2 over there, however they want to do it. So that's how I'm going to get them to think about at least that part. It's not exactly the counting up. We can definitely then share that with them. Okay? So there's going to come a point in first grade where I'm going to give them a sheet of these problems here, of subtraction problems, and I'm going to have a blank line, again, just like we had before. Have a blank line underneath it, and to first find a matching addition fact. And they put it in that blank line, and then they use it to help them with the subtraction fact. But we aren't going to go through like we did with the addition facts, you know, one by one, trying to figure out what's a shortcut way to figure those out. This is the shortcut. So basically we're just saying you learn all these facts, these addition facts, so your subtraction facts are going to rely on those. Okay? Now, just before you make this, they're able to realize this, because you know they don't necessarily. I haven't told you how they're going to know that one's the opposite of the other, one's the inverse of the other. Okay, can you figure out a way I can get them to see that subtraction's the inverse of addition? Just spend a few minutes, see if you can figure out a way to get them to see that. Because they need that to do this skill that I just showed you here. They need to know that addition is the inverse of subtraction, and the numbers are the same. How am I going to get them to know it? Any ideas? Lauren? Oh.
When I was little, instead of subtracting, I would like kind of look at the equation backwards, I guess, and be like, what plus 4 equals 12?
Okay.
And then figure it out that way.
Now figure out the subtraction. Okay? How do they know they can use the addition?
It's not something that you tell them?
No, how are you gonna get them to figure it out? You always wanna try and get them to figure it out. Now, I know there's a lot of things that we haven't figured out yet as teachers, okay? And so we have to sometimes just tell them, because, we have nothing else we can go on. But I'm just saying to you, so you're figuring out a way for them to figure this out.
Well, if you use manipulatives at first and you have, your problem, then from there, once you separate your 12 minus 4 and your 8 on the side, then maybe the kids will see that, oh, but if I bring the 8 with the 4, then that equals 12, and then that's how you kind of will get that problem.
Yeah, that's pretty much it. So if you have 12 take away 4, and they have the manipulatives, and they take away 4, now they have a pile of 8, and they have 4, and you can say, okay, 12 minus 4 is 8, we write it down. And you say, now what if I would bring those together? What problem is that? And 8 plus 4 is 12. Okay, and I could write that on the board too. All right, I can do a second one, do the same thing, okay, and they're creating an addition sentence after they perform the subtraction, okay? After doing a few of those, they're going to see, oh, they're going to notice when I put up on the board, I'm going to say, what do you notice about these numbers? Okay, in these pairs, okay, the numbers stay the same, all right? Do you suppose it's always going to be like that? Okay, so I give them another problem, okay, and say, what would the addition problem be for this? Okay, and making the connections that you guys are talking about. All right? So it's always just trying to figure out how can I get them to see it? And that's really hard for us, because we weren't a part of that type of a class outside of 111, 112, 113, and in here too. Okay, so we've never really thought about it. Okay? All right, so very good. So with manipulatives, they can certainly see it, and you can generate the abstract data on the board, and then they can explore patterns and everything. Everything's coming again from these fundamental concepts. If we use these concepts, they can tell us. Okay, so we have the concrete again, we have contextualized. Anytime you use manipulatives, that's in the context. Okay? They're understanding what we're doing first. They're spreading those things apart, then they're bringing them together. They understand what both those things mean. Okay? Now they're finding patterns. And when they find a pattern, that's creation in blooms. Okay? They created a pattern. They created the rule. They're telling us that they're both the same. We just would give it a name, inverse, which we wouldn't tell a first grader that. We won't say inverse, but they can see it. They're the same. They're the opposite. Okay, whatever they want to say. Okay? So that's what they've created. All right? Now, on the board, we've got 4 types of subtraction situations, and that's also on Blackboard. I showed you that file last time, okay, on Blackboard. And usually, we introduce the subtraction with, when I was talking about like the frogs or whatever, change takeaway. Okay, so something is going to change this time where something's being taken away. So you see the similarity. The other one was change, add to. I can't think what exactly it was called. Change. Is that what it was? Add to. Change, add to. Yeah, change, add to. Okay, so you see the direct relationship between these two.
These slides are on Blackboard?
Yeah, matter of fact, let's just go here in the course documents. And if you go down, basic addition facts notes. Oh, no, here we go. Types of addition and subtraction word problems. Click on that. Types of addition and subtraction word problems. And there's the first slide. And then there's one we're looking at right now. Okay, so there's a change takeaway. That's usually the way we introduce subtraction. You saw me do that here. putting on the board, I'm playing with so many, I give some to Lauren, how many do I have left? Okay, that's me introducing it. Here's something, just the opposite. The other one was part, whole, where you already had two parts, and you brought them together for the whole. This is whole, part. This is just the opposite. Bobby has 7 blocks, some of the blocks are red and some are yellow. If Bobby has 4 red blocks, how many yellow blocks does he have? So nothing changes here, but it's still subtraction. And that's a tiny thing for us, but for them that's a big deal. Okay, because they think something has to change to use subtraction. Yes?
So this is kind of jumping to the next one. Because we've talked about like how many more questions.
Yeah.
How do you I understand this may just be my brain, but how do you get them to not see addition when they look at more?
Okay, well that's when we talk about the key
Yeah.
words, that you don't want to emphasize those key words because something exactly like that is what will happen. So if you emphasize, look at the word more, they're going to say 9 and 5 is 14, okay? So what you want to do, and it's kind of in that vignette too, where they were talking about, where the kids were talking, that's what you want. If you can get your kids to discuss some of this, which is hard to do at this age level, but if you can get them to start figuring out and talk to each other what it should be and why, now they can start to understand, and that was the key in that vignette. They were saying, one said, well, it says more, therefore you have to add. And then the one says, no, but look at the problem, it says to do this. All right? So as a teacher, you could go ahead and you could say, if it happened to be an addition problem, you could say, what made you do that? And they're going to say, well, the more made me do that. Okay. In this case, it didn't work. You just don't want to teach keywords for that very reason.
Even if they don't if you don't explicitly teach them, don't they start to associate addition is more?
They could, yeah. And so that's where, a problem like this would come into play, where you'd say, okay, show me. If they said, Tanya has 2 frogs, Jan has 6 frogs, how many more frogs does Jan have? And they say 8. Say, okay, let's just do this one. Okay, so I'm Tanya, I have 2, and Jan, you have 6. How many more frogs does Jan have than me? Okay, so again, anytime something happens, always think about, I'm going to go into their language, the concrete. Because exactly what you're saying, in the abstract, we can make very logical mistakes. So we always try and go back to the concrete. And that's what the one teacher did. Do you remember when the boy said it was 12, the answer was 12, and she went up, okay, listen, she counted them again, she went very concretely again, okay? And that's what you want to always do, say, okay, that's what they understand. Okay, she didn't say, no, you're wrong, she just said, let's do this. Then she said, well, how many are there? He said, 11. Okay? So that's good, those are good questions. They don't occur to us all the time, to go back into the concrete. It just doesn't occur to us because we aren't used to doing that. Okay, I gave you, these last 2, compare and equalize. They're very similar, just like with the addition ones. I'm not going to ask that you know the difference between them. I really have a hard time finding the difference between them. You're just comparing 2 things, but there's no takeaway. One person doesn't have 2 sets, like I have 7 blocks and 3 are red. Okay, so this is just, you're comparing 2 quantities, you're equalizing them. Now's the part where, remember before we had similar problems to this, and for us it seemed odd that you use addition. Okay, like this one here. I think it's the same exact wording. Okay, at this point, no subtractions. Let's say go 2 plus 1 equals 6. Okay, that's how they would solve this. Now they're going to have some trouble because they're so, just like us, especially in the middle class. You know how we keep going back and we keep relying upon what we already learned, and it kind of interferes with us. But same with them. They're going to say, I know addition very well. They're going to want to make these into addition problems when you're teaching subtraction. So that does take a lot of patience on your part. Okay? To show them that. They will make them into addition problems. Okay? All right, I didn't get to this back families yet, so we'll save this for next time.